All right, let's look at C2. C2 says a 2 times 10 to the third kilogram car accelerates from rest under the actions of two forces. One is a forward force, so I'm going to call that FA. It's not really an applied force, but it's pushing it forward, so we'll call that FA, 1140 newtons, provided by the traction between the wheels and the road. The other is a 950 resistive force. So a resistive force is friction due to various frictional forces. Use the work kinetic energy theorem to determine how far the car must travel to reach its speed. So how far the car travels is d. So the work kinetic energy theorem says work is equal to the change in kinetic energy. And we learn that work is equal to FD, and the change in kinetic energy is KEF minus KEI. If I rearrange this to solve for D, D is equal to KEF minus KEI over F. So D is equal to, now we know this is 0, so I'll get rid of that. So it's 1/2 mvf squared divided by F. Now, when you look at your given, you'll say, well, wait, what F am I going to use? I have an applied force, which is making the car go forward, and then I have a frictional force that's acting in the opposite direction. This is the net force. So if you want, what you can do is you can draw to the side. You can say, well, let me draw a little free body diagram. And don't worry about the weight and the normal force. We're just worried about the net force going in the direction in which the object moves. Because remember, work is only done in the direction if an object moves. So if an object is moving horizontally, we just want the net horizontal force. So I have FA minus FF. There's my sign convention. So my net force is just the applied force minus the frictional force. So my net force is just going to be 1140 minus 950. So my net force is just the difference, which is 190 newtons. And that is what goes here. So it's 190 newtons, and then 1/2 m times my final velocity squared. I think I forgot to write the final velocity in the given. Yeah, the final velocity they told us was 2 meters per second. So this is 2 meters per second squared. So when we do all this, D comes out to be 21 meters. What did we have to know in this problem? Well, first we had to know the work kinetic energy theorem. Work is equal to the change in kinetic energy. We had to remember that work is equal to F times D. The change in kinetic energy is the final minus the initial. We had to know kinetic energy is 1/2 mv squared. The key to this problem was that work is only done in the direction in which the object is displaced. So when we're looking at the force that causes the work, it's only the force going in the horizontal direction, but it has to be the net force, because I have one force this way and then one force in the opposite direction. So it's the net force going in the direction in which the object is displaced. So some of you maybe could have done this in your head. If you're not sure, you draw a free body diagram, and the free body diagram helps you to visualize what's going on.